Evening, all of you. Good evening. Request like one desk to be left empty. This one, so that I can keep my stuff. Okay. So welcome all of you. I'll be teaching physics portion from your science portion, right? So my name is Uday. I think not full name. And I will be starting with motion. This is chapter 8. This is chapter 8. So today we'll understand what is motion, rest, types of motion, right? Concept of distance, displacement, and then uniform motion, okay, so these things we'll try to learn. We'll also see what is scalar, vector, what are these quantities, scalar and vector quantities. So this is a very, very important chapter in physics. Those of you who are planning to make career in science, okay, you should obey this chapter, follow this chapter very carefully, especially those who want to become engineers. So physics is very, very important. And the way you have to learn physics is mathematics is the key requirement to understand physics. So it is application of mathematics. Okay? So your mathematics needs to be good to be a good physicist or engineer. Okay? So whatever mathematics is needed, I will anyway explain. So the approach to learn physics is very concept based. Okay? Not memorizing. You have to understand. Okay? So once you understand, memory is not a problem. It will become part of your personality. So try to understand the concepts. Okay. So these are key terms that we'll try to understand. So motion. Everybody is familiar with motion. Everybody knows motion. So what is a motion? How to define motion? Let's say this object is moving. It's moving. So what is happening to it? This is its initial position. It's in motion. then what is happening? It is reaching some final position. So how do you describe motion? Is it started in your schools? Any? Okay. Started, right? So you tell me.
Motion is something which an object does having
Yeah, you're right. I mean, little bit more. So this is what we do. Okay, so we know things, but then we have to articulate. We have to present it. So study is all about that. Describing what is happening, observe and put it in words. Okay. So yeah, what is happening? It was here, now it is here. Because of motion. So what happened? What changed?
in position.
Change in position.
An object is set in motion when it is continuously moving and changes its position.
Yeah, okay. Don't take stress, okay? Everybody try. Yeah, you want to solve that?
I'm going to say that.
What?
If change is a change in position,
Change in position with respect to?
with respect to time.
Yes. Time and surrounding, space. So surrounding is not space. That's it. That is motion. So whenever a body undergoes motion, so this is how you write. A body is said to be in motion if its position changes with respect to some reference point. Okay, so WRT is with respect to. So body is said to be in motion if its position changes with respect to some reference point. That reference is space and time. Okay? So standard reference. Let's understand what are the different types of. This body can move in how many different ways? That is a type of motion. But what is this motion?
Uniform motion. And not
Have we started uniform motion? What motion is this? Motion in a straight line. Very familiar, right? All car, aeroplane. We walk. How do we walk? Straight line. We walk like this? No, not like snake, right? Straight line. So human walk is a straight line motion. What about snakes? So what is this? Zigzag motion. Okay. So is it a straight line motion? What motion is it?
Non-uniform.
Uniform, forget about it. Don't use uniform. We'll come to it.
Zigzag.
Zigzag, yes. But is it a straight line? It's a motion in a plane. So it's a two-dimensional motion. Straight line was one dimension. Okay? So you can have a motion in a straight line. Or you can have a motion in a plane. Right? Or you can have a motion in a space. So what is a space? Like it will have three dimensions, right? Like when a plane is taking off, where is it going? Is it a straight line? Straight line?
It's a curve.
It's a plane also, plus it is going above the ground. So there is x-axis. So you have x, y, and z. three axes are there. Here you have x and y axis. Are you familiar with axis? Graphs you have done.
Yes.
So you have x and y axis.
Yes.
Now graph in your notebook is a plane. So and this is a plane. It has only two dimensions, the length and breadth. Okay. So a sheet of paper is a surface or it is a plane. So plane is always two dimensions, right? Anything which makes a motion in only one direction, then it is a linear plane, like a piece of a wire. Its length is much more as compared to its thickness. So what dimension it has? It only has length. Its thickness is negligible. So length only in this case, here you have length and breadth. Here you have length, breadth and height. Yes. This you study in mathematics, but in physics, you will understand it with more deeper perspective. Okay? So it's not going to be rote learning, it is application. Okay? So bodies which only have length are called linear bodies. Okay? Such bodies are called planar or laminar. Lamina, like a plain sheet, lamina. Okay? And these are 3D objects. So anything which is linear is also called one-dimensional. This is called two-dimensional. This is called 3D. Everybody has signed it? Okay. So why I am telling you all this is there will be reference and you should be able to understand. Whenever I am referring to 1D, 2D, 3D, you should understand. So motion everybody understood. So when do we say the body will be at rest? At rest, if its position does not. At rest, it does not. Okay, so by comparison, you understand what is the meaning of body at rest. Now, is it possible that you see a body moving, but somebody else sees it at rest?
Yes.
So therefore, motion is not an absolute thing; it is a relative thing. It means different things to different people. ये क्या हो गया? है ना? So this is where you have to understand physics in a more subtle way. It's not direct. I mean, you may be seeing something, somebody else will see something else, and they both fight. हाँ, एक बोल रहा है कि नहीं move हो रहा है, एक बोल रहा है कि नहीं move नहीं हो रहा है. Both of them are correct. So can you give me an example where a motion is taking place?
Train.
Explain.
Like two parallel trains are one is going here and other one is going here. So
Okay, so the example is train is going in this direction, say east. Let's say this is the direction. Right is east, left is west. One train is going east, the other train is going
west.
west. Okay. What is rest and what is in motion? What is in rest and what is in motion?
Both are
Both are.
in motion.
So both are in motion. And what? No, in the same motion, somebody should say it is moving. Somebody should say it is at rest. Not tell me.
In the
Wait.
same-
Have you tried fully? This is a motion, but what is in rest in this? Done?
East one thinks that he is in rest, and other one is in motion.
East one thinks that he is at rest.
Yes.
So let's say he's a driver of the train, okay? He's the driver of the train. So how can he think he's at rest? He's seeing that he's moving, he's coming down.
He is in motion and other one is in rest.
How? He will see that this train is passing, so how the other one is at rest? Wait. will go downward. You got it? So no, with this example we cannot, it's not a correct example which can describe both motion and rest. Because both are in motion, right? And they are seeing that the other body is moving past them. Because the other guy is able to see, na? Like this. Okay. What if you would have said that both are moving in Z? Now they can say something is at rest and something is moving. How? Now explain. Explain. So everybody, so from interaction it's learning for everybody, right? Can somebody, can you explain what is at rest now in this case? And what is moving?
Yes. So what case?
In the second case, when both the trains are moving towards east. Or car, let us say, keep it cars, small or compact. So therefore, if both of them are looking to each other, they're always together. Let's say they're moving in the same direction with the same speed. Let's say this is moving with 80 km per hour. This is also moving at 80 km. So they are on the track, so no need of any accident. Huh? No, I mean, threat of any accident. So both the drivers will see each other talk. Suppose if they were able to talk on a walkie-talkie. So they are at rest. But when they in front, they see in front, then they are in motion. So it depends on the reference. What is the reference? With respect to each other, they are at rest. Okay? But with respect to ground, they are moving. Okay? So motion is, so such kind of discussion is called relative. Motion is a relative concept. Therefore, motion is relative. I'll give you another example. Are we moving? Are we moving?
Yes, sir.
Okay. No. Why no? Because we are fixed with respect to each other. Our positions are fixed. So we are not moving. Everybody agrees. Explain how we are moving.
No, it's just rotating constantly.
Very good. So if somebody watches us from space, and let's say he had an X-ray vision, he enters into the room, he can see us. So he will see that Earth is carrying us, and we are rotating with Earth. So it depends from where you are watching the motion, right? So from it all depends on the reference point. Who is the observer? A motion is a motion. Either it is a motion or not a motion, depends on the observer. Okay? You all agree? Good. Is it taught in the school? नहीं, ठीक है. तो fiction की books पढ़ता है क्या? Everybody comfortable with English and Hindi or Hindi you understand? ठीक है, चलो. So good. अगर नहीं पढ़ा है chapter तो भी इसने बोला तो it's a good observation. ठीक है? So everything. So that's why अगर कोई तुमसे झगड़ा कर रहा है, don't believe anybody. It's in life also. मैं बोल रहा हूँ ना, ऐसा ही हुआ है. मान ले मेरी बात. उसको ठंडा करने के लिए ओके करके भेज दो. आर्ग्यू मत करो. Because you don't know. ठीक है? The perspectives are also different. So physics में life सीखोगे तुम लोग. It's very close to life. Not only biology, physics is also about life. Everything that we are learning is derived from life only. So if you understand physics better, you understand yourself better. Good motivation to learn physics. Okay. So what is relative? You understood? Difference of perspectives. That is called relativity. Relativity. Einstein's theory of relativity. You see there. Okay? यही से आता है. Next. Now what is distance? So when a body is, let's say, moving from point A to point B. Okay? So let us say it can go in a straight line. let's say A is Mumbai, B is Pune, right? So it can go in straight line, or it can take some other route, the old Bombay Pune route, right? There could be various paths to reach the destination. Or somebody else say even a longer route सब घूम घाम के ऐसे पहुंच गया. So let's say one is you went by plane, by air, so straight, right? Then you took a, let's say, old Bombay route, old Mumbai Pune highway. Then somebody decided, no, I'll go to Nashik and then I'll go to Pune. That is also a possibility. Okay, so via Nashik. Okay, so these are all different routes. So what is the distance? Distance is the value of actual path length. Okay, let's say if we took this route, it was 130 kilometer. This was just 100 kilometer. Right? Via Nashik, let us say it was all for 170 kilometer. So this value, the path length, actual distance covered is called actual path length covered is called distance. Okay? So distance is the actual path length covered by an object during motion. Or object undergoing motion. Okay? So like this. Right? Then what is displacement?
Shortest distance.
Yes. कैसे बता रहे थे यार? पढ़ा है तुमने? You have studied it.
नहीं मैंने पता है.
पता है. बगैर पढ़े कैसे पढ़ा? Because something like correct. He is right. Shortest distance. But something is missing. Shortest distance, yes. In a specific direction. Okay? So you have to add direction, sense of direction also. अब यहाँ पे देखो, यहाँ से यहाँ तक इस direction में गया, फिर direction change हुआ, फिर ऐसे change हुआ. Everywhere the direction is changing. ठीक है? But in case of displacement, the direction is specific. It is left to right in this example. So, displacement is the shortest distance between the 2 points in a specific direction. So, it is not only 100 kilometer. 100 kilometer you will say towards east. You have to specify direction. So, this value is called magnitude. What is it called? Magnitude, and this is called direction. Right? But here you only have magnitude in case of distance. Okay? So these are the different types of physical quantity. Such physical quantity which can be described only by its magnitude. They are called scalar quantities. Understood? So scalar quantities only have magnitude, like mass, like time. Time doesn't have direction. Okay? Temperature. These are all scalar quantity. But if I say velocity, force, so So 20 Newton force in which direction? Okay, so that way. So there are certain quantities which can be described only if you specify both its value and magnitude and direction. Such are called vector quantities. Is it clear? So therefore, distance is a scalar quantity, whereas displacement is vector quantity. So what is displacement? First we define it. Is the shortest distance between 2 points in a given direction. Okay. So distance is a scalar quantity. Displacement is a vector quantity. ठीक है? So now let's understand what are types of motion that we are going to study in this chapter. So everybody clear till here? Is the concept clear? What is scalar vector? What is the difference between distance and displacement? Okay. So we already discussed two types of motion: straight line motion and circular motion, right? So examples of straight line motion is person walking in a straight line or car moving in a straight line. Anything moving in a straight line. Any other example of straight line motion? This is in the horizontal plane on the ground. Right? What about this motion? Everyone. Is it a straight line motion? No. Is it straight or no? If I throw it like this, is it straight? Let's say it goes up and comes down. Is it a straight line motion? So motion in free fall. Okay? Motion in free fall. Okay? These are the two types of straight line motion. Then circular motion. What is circular motion? Any object moving in a circular path. Path, here it is straight line. So what defines the motion? The path. If the path is straight line motion. If the path is circular, it is a circular.
So can we say that a pendulum is moving in a circular motion?
It is oscillatory motion. To and fro. Okay. So this is, and we will learn something called as uniform circular motion. Uniform circular motion. So I'll ये we are going to study. Okay. The third type of motion that we spoke of is to and fro motion. So oscillatory or vibratory motion. But this is an advanced motion. You learn about it in higher classes. Okay? I don't know if pendulum is there in this class. Sound wave is there, right? Is it there in this? Sound wave, I think, is there in fact. Or is it in 10? Yes. So you will learn about it. To and fro or oscillatory motion, you learn in sound chapter. But right now, only these two things. Okay? So more about it later. Right now, I just told you. We are going to learn about. Okay. Now, what is uniform and non-uniform motion? Can I erase this side, the right side? Erase it. So you have your UT volumes and books where you'll get definitions and all. Try to understand the concepts because once you understand it, those definitions you can then memorize easily. Okay? Memorizing definitions will be easy if you understand the concept. Okay. So feel free to ask questions, stop me, ask questions if you have. Then what is uniform motion? Oh, before that, there is something called as rate of motion. Do we have rate of motion before it? Okay, uniform motion. Uniform. So uniform motion में क्या होता है? A body covers equal distances in equal intervals of time. So let us say the total distance between 2 points is 50 meters. Right? This is 50 meters. So 1, 2, 3, 4, 5. Each is 10 meters. The total is 50. So 0 to 50. And let us say the body travels 10 meters in 1 minute. Okay? It covers 10 meters in 1 minute, 20 in 2 minutes, 30 in 3 minutes, 4 and 5 minutes. This is how. So this is the time taken to cover 50 meters. Okay? So you can see that in every 1 minute, body covers how much?
10.
10 meters. Here also, to go from 10 to 20, what is the actual distance? 10 meters. What is the time interval? 1 minute. Right? So every time interval of 1 minute, the body travels the distance 10 meters. Such motion is called uniform motion. Okay. Now let us see the next type of motion. So how will you put it in words? In this case, the body covers or moves equal distance in equal interval of time. Okay. next example, non-uniform motion. Okay, this is time and distance in meters. So in the first minute, the body travels 5 meters. Okay. By the end of second minute, it reaches 12. So what is the time interval? Let's write the interval. The interval is 1 minute. So all the time interval is how much? 1 minute. Now in the first minute, it is 5. Next minute, what is it? 12 minus 5 is 7 meter. What about this? 5 meter. What about this? 18 meter. What about this? Is it 15? So in this motion, the distance covered by the body is not same in every 1 minute. Okay? So here what you will write, in this case the body covers unequal or unequal distance in equal interval of time. Time interval is same, but the distance covered is not equal. Okay? So in this case, how do you define? In this case, body covers unequal. Is it unequal or unequal? Okay. Unequal distance. Says in space, equal intervals of time. Okay. So what kind of motion is straight line? 1D, 2D? 1D. Right? Because it is in one dimension. What about circular motion? 2D. 2D. Because it is in a plane. Right? So it's in a plane. It is a 2D. And for two throws, any vibrating object like needle of a swaying machine, it goes like this, right? Any engine, 2D. 2D, yeah. It is kept in a separate category only because here the body is making a motion at the same place, and because of that something else happens. So we are not categorizing it as 1D, 2D. Just so this is totally a different category of or oscillatory or vibratory. Okay. So it is a motion in a plane. Motion in plane. Okay, so let's not complicate it. Can I erase this part?
Yes.
Any questions still here?
So I can give example.
Of I mean, if you walk, see your watch. If you cover say 100 meter every 10 minutes, you are doing uniform motion. And if you don't do that, then it is non-uniform motion. It can be true for anything, any order. This is the general definition. Put any body. Body means anything you put in that place. That will be fine. So one real life example is when you are traveling from Mumbai to Pune, right? Is the vehicle, say you have taken a Ola cab, is it undergoing uniform motion? Or no? Huh? No. Why no? There will be traffic, there will be no traffic, there will be signal. So always the real life example is non-uniform only. So uniform is an ideal concept. Okay? Hope it is clear. Now we define rate of motion. Rate of So whenever we bring rate, whether it is physics or mathematics, right? It has got something to do with time. So we are talking about motion, that is distance covered, right? So how much distance is covered in unit time? How motion or distance is changing with time? That measure, that is defined as speed. Okay, so what is speed? Have you studied about speed? Speed is defined as rate of change of motion or distance upon time. Okay, how the motion is changing with respect to time? That is called rate of motion. So it describes the rate change of motion with respect to time. Okay, so how do we define speed? Rate of motion is anything to do with how the motion is changing with respect to time. Now there are some parameters. One is speed. So what is speed? How do you define speed? Speed of an object is defined as distance covered by an object in unit time. Okay, so this English statement mathematically is written like this. So what is the symbol of speed? V is equal to S upon T. S is distance or displacement. S is the symbol for distance or displacement. Okay, if body is moving in one direction and then its distance and displacement are same. That's why S is used.
V is speed.
Yes. It is also velocity. In 9th standard, but in higher standard, you will get this symbol, vector, direction area. So right now, the symbol for speed and velocity is same. Just this thing will change. If s is distance, then it is speed. If s is displacement, then it is velocity. Hold on, we'll go slow. Concept.
So the rate of motion is anything that changes
With respect to time. That is rate. Let's say you are heating an object. So change in temperature with respect to time is rate of heat. Okay. यहाँ पे when we say speed, it is rate at which the distance is changing with time. So if the car is moving with higher speed, it will cover more distance. If it is moving with less speed, it will cover less distance. So the rate of motion. If you know rate of motion of any body, you can figure out how much distance it will reach in a given time. Because distance is speed multiplied by time.
Or how much time will it take to reach a distance?
Or how much time it will take to reach the given distance. Yes, exactly. This is rate of motion. Like if you have two cars, how will you differentiate the fast with the slow? Depending upon the time. So rate describes that. Okay? All right. So speed is defined as the distance covered by an object in unit time. So for example, if you had a body in time t, it covers distance s. So what is it? Unit time, no? So in t seconds, a body covers s meter. So in 1 second, by unitary method, it will be s by t. This is what is speed. Okay, so this is nothing but plain application of unitary method. Like if any object in t seconds covers s meter, therefore in 1 second how much it will cover? S by t, which by definition is speed. So it is defined as distance covered by an object in unit time in 1 second. Unit time is 1 second. Clear? Okay, so we are studying it from all sides. So get used to it. Okay. So then if you understand all this, then you know that what we are writing in English, simply put, is this. Now you don't have to memorize. So in the numerator, the quantity is changing with respect to time. So if it becomes unit time, right? If I know that it took 5 minutes to reach 50 meter. Okay. So in 1 minute, how much it will be? 50 upon 5. And in second, divided by 60 again. Got it? We have to always follow SI units. So second will again. So we'll understand all that. So what is the unit of it? So what is unit of speed? S is meter. T is second. Meter by second or meter per second. This is how the unit of speed is. Okay. Clear? Because distance ka unit is meter. This is the unit. So unit is always measured in meter per second. I mean, speed is always measured in meter per second. So like I said, in real life, the motion is generally non-uniform. So what is a uniform motion? A body moving with a constant speed. Right? A body moving with constant. Take any distance. Like in the previous example, 50 and 1, 2, 3, 4, 5. So this was how much? 90. So from here to here, what was the speed?
10.
Let's instead of minute call second, okay? For simplicity of calculation. Let's say it took 5 seconds to reach from here to here. 1, 2, 3. So what is the speed here? 10 by 1. That is 10 meter per second. right? This is the speed over here. So I'm writing the speed for all these intervals. What is the speed from here to here? So again, what is the distance covered? 20 minus 10, 10. What is the time? 2 minus 1, right? So again it is 10 by 1, so 10 meter per second. So in uniform motion, the speed will be constant. So in uniform motion, speed is constant. Right? In non-uniform motion, this was 10, and if you see the data of your old example, you will find it will not be 10, something else it will be. Okay? So between the same time interval, the distance covered is different, therefore the speed also will change. Clear? So you'll come across all this. In uniform motion, speed is constant throughout the journey. Yeah. Or through application. Journey counter between the initial and final position. Okay? So this is also called destination. This is called starting point of the motion. Okay. So any explanation you need till here? So now we have very little time left. So I'll ask you questions so that you answer. Huh? I mean, I will judge whether you understood it correctly or not. Okay. Okay. Let us say this is some track. Okay. And this is the point. I'm calling this point as O, from where the motion starts. Right? So this is right of, and this is the left of. So these are what? Direction. So what is O? O is the reference point from where my motion will start. Okay. And let's say this is 10, 20, 30, 40, and 50. This is 0, minus 10, minus 20. Okay. So this reference point is also called as origin. What is it called? Origin. Okay. So whenever we measure distances, we need some reference, and if it is a scale, there also you see a 0. So 0 is the reference point, okay, and it is called as origin. Now I'll give you various motion scenarios. The object goes from O. So I'm going A to B. Okay. And then goes from B to C. Then comes back from C to D. So I'm writing the upper line. So this is how it goes. And then from C it returns to D. Then from D to E. This is the different stages of motion of an object. Same body undergoing straight line motion. Okay. Now first question. Distance covered. Till C. So tell me, what is the answer for this? Distance covered
50.
till C is so 50 meter. right? Now what is the displacement?
Also,
Huh?
also then.
Also 50. So distance is 50. So let me put it in the form of a table, right? Table. Distance and displacement. So I'm saying from O to C. What is the distance? Is it 50 meters? What is the displacement? Is it again 50 meters? Okay, is it correct? What is missing in displacement?
The direction
So 50 meters, either you say towards right
or east.
or east if you have defined the direction, or you put a plus sign. Right is always plus sign, left is minus sign. So displacement value should also have direction. Then it is. Now, so it goes from O to C, then comes back to D. Now tell me.
Distance 90.
So distance is what? Full path length 50, and then B is how much? 50 minus 10, 40. So this is 40 and this is 50, 90. Very good.
Displacement is 10.
Displacement is
10.
10. How? How do you define displacement?
Shortest distance.
Shortest distance. So final position minus initial position. What is the final position at D?
10.
10. So it will be 10 is final position, right?
Yeah.
And what is the initial position?
0.
0. Very good. So this is 10 minus 0. This will be equal to 10 meter. That's it?
To the right.
Yes.
To the right, which means plus. Yes. Okay? Or you say to the right or towards east. So you have to specify from the initial position where is it. Now the last part. B now to B. Now for this full part, tell me what is distance, what is displacement?
130 is distance.
Okay. So distance is immaterial. I mean, it irrespective of direction, you have to go on adding the actual path length. Okay. So this is 50, and again 50, and plus 20. So 50 plus 50, 100, 120, right?
100.
Yes.
E, 120. What you had said?
I said 30.
130. You probably thought E is still good. Now what about displacement?
Minus 2.
Yes. So it is, what is the final position? Minus 20, minus 0. This will be minus 20 meter. So 20 meter on the left. Okay. So this is the displacement. Is anybody having any doubt in this? This is a very good example to clear your doubt on distance and displacement.
Sir, can you explain that again?
Which one? Which one?
Last.
Last point. So body is starting its motion from point A. Okay, OC नहीं लिखते हैं, A था ना? A से start होगा. Okay. From A it travels to C by traveling 50 meter. We are now calculating distance. Then from C it is going back to D. So C to D how many meters? 40. है ना 50 minus 10 कितना हो 40. So 50 plus 40 90. Then from 10 to 20 how much? Huh? This is 10, 20, 30. So 90 plus 30 is 120. ठीक है? This is total path length till E. From A to E is this one. ठीक है? Now what is displacement? What was the definition for displacement?
Shortest.
Shortest distance between the final and initial position.
With respect to direction.
in a given direction.
Yeah,
In a given direction. So the direction of motion is in this direction. So we are specifying that this final distance is in which direction? It is in the left. So either I write minus 20 meter or I write 20 meter towards left or on left. With respect to origin. It is on the left. Have I answered your question?
Yes.
So I think today we'll stop here. Next class, if you have any doubt, I'll clear that and then we proceed further. Try to do some questions in the book on the topics you're discussing.
Can you tell when is the V velocity and when is its speed?
Velocity we haven't covered yet. So velocity,
When is the
I'll
V
tell you.
velocity?
I'll tell you. When this definition changes to, instead of distance, now it will be displacement. On time. This I will cover separately, don't worry. So
Speed
speed,
in a straight line. Speed in a straight line.
that displacement covers that. When I say displacement, it means that. What you're saying is inherent in this. So this is just a formula. When we define, then we say. Okay. So we are still not done with speed. There is average speed, concept of average speed. All those things are there. So we'll cover that. And your understanding of these terms is very important for you to be able to solve numericals. Because numerical, there is a play of word. कहाँ पे speed डाल दिया, कहाँ पे average बोला है. तो उससे फिर your approach has to change. Okay. So we'll finish speed portion and then we go to velocity. So right now, I would suggest you don't write velocity. We'll do that separately. Okay. All right. See you in the next lecture.